Since log functions and exponential functions are inverse functions of each other, and we saw the exponential equation has a graph like this, then the logarithmic equation will have a graph that's flipped across the y equals x dotted line. So this feature over here is a horizontal asymptote, becomes a feature down here of a vertical asymptote. The intercept, the y-intercept on the exponential equation becomes an x-intercept on the logarithmic equation. So the exponential equation 2 to the x equals y, and the logarithmic equation log base 2 of x equals y have graphs that are mirror images across the y equals x dotted line. What can we say about the domain of the exponential equation? It is all real numbers. What can we say about the range of the exponential equation? Well, those y values that we can use are from 0 to positive infinity. So, looking at the graph, what can we say about the domain of the logarithmic equation? The x values we can use are from 0 to infinity, and the range is all real numbers from negative infinity to positive infinity. Notice, just like before, the domain and the range flip, because the way we get these values is we switch the role of x and y. So that point right there is an xy point, which would match with this yx point. So the domain and the range switch places. With that in mind, we can graph some logarithmic functions. If we have y equals log base 3 of x plus 1 minus 2, we know the basic shape of a logarithmic function looks like the green sketch up here. The 3 is going to determine whether or not it's more steep or more flat. Inside here we see a left or a right shift. Outside we see a vertical shift. So, listing the features that we see in order to sketch this, first we see a shift to the left 1. Then we see a base of 3. The base of 3 means it's going to be a little bit flatter. It's going to be flat, more flat, because the 3, if you think about exponential functions, if I had a base of 3, that would make the exponential function steeper. So a log with a base of 3 will be flatter. Next, we see the negative 2, and that's going to make everything go down by 2. So we'll start off with a generic sketch of a log graph. We know the feature it has is a vertical asymptote and an intercept. So there it is, vertical asymptote and an x-intercept. So now we're going to move everything to the left 1 and down 2. Left 1, down 2 puts a point right here. That was our intercept. If we move our vertical asymptote left 1 and down 2, now it's right here, and it's kind of goes like that. If we'd like one more point, what we can use is the base of the base 3 to pick a point. What are convenient values to pick? Well, some values that we might want to pick for log base 3 of something, the values in here that would be convenient would be powers of 3. That is, numbers like 3 or 9 or 27 would be convenient to have in here, because as we saw in the previous video, if you had a power multiple in here, when you change it to exponential form, it works out to a nice number. So in general, if I have log base a of 1, I get 0. That was our intercept. If I have log base a of a, I get 1, because a to the 1 equals a. If I have log base a of a squared, I get 2, because a squared is a squared. So what would be another number for x in this problem that would give me a convenient value? Well, if I can get the inside part to be 3, that would be convenient. So if x were 2 plus 1 would give us 3. Log base 3 of 3 is 1. 1 minus 2 is negative 1. So then right here would be the point 2, negative 1. Another convenient value would be if the inside were 9, that is 8 plus 1 gives me 9. Log base 3 of 9 is 2. 2 minus 2 is 0. So over here would be the point 8, 0.